Hi, my name is Oktay. Welcome to today's video about the chemical element calcium. This is a picture of calcium metal. It has the atomic number 20. Its name comes from the Latin word calx, which means lime. And there are 6 isotopes in nature. The most abundant isotope is calcium 40. Second is calcium 44, and there are 4 more calcium isotopes. This is a picture of the periodic table. Calcium is located in the second group. It is a member of the alkaline earth metal group, and its origin is from exploding massive stars and white dwarfs. Calcium is an essential element, and the human body contains 1.2 to 1.4 kilogram of calcium. This is a picture of the abundance of the chemical elements in Earth's crust. Calcium is here. It's very abundant. It is a number 5 in abundance. This picture explains why calcium is so abundant. It is a picture of the nucleosynthesis of the lighter chemical elements. At the top left, that's the proton-proton chain that makes one helium-4 isotope out of 4 protons. At the top right, that's the CNO cycle. That's another mechanism of nuclear reactions that also produces helium-4 from 4 protons. In the middle, that's the helium-burning triple alpha process. That makes helium-8 out of 2 helium-4 isotopes, which can merge with another helium-4 isotope to carbon-12. In this chain of reactions, there are 2 bottleneck situations. One is the beryllium barrier. That's the low half-life of beryllium-8 of just in the order of 10 to the minus 17 seconds, which means most of the beryllium-8 isotopes decay back to helium-4. And there's another bottleneck situation, that's the Hoyle state of carbon-12. Again, this high energy state of carbon-12. Most of the carbon-12 isotopes decay back to helium-4. But in a dying star, there's enough time to try again and again, and eventually you get carbon-12 isotopes in the ground state. They can enter the alpha process of a merger with more helium-4 isotopes. Then you get oxygen, neon, magnesium, silicon, sulfur, argon, and eventually calcium. And this explains why the calcium-40 isotope is so abundant, because it's a direct product of the second most abundant element in the universe. That's the helium isotope 4. These are 3 examples of calcium minerals. At the left, that's limestone, calcium carbonate. In the middle, that's dolomite, calcium magnesium carbonate. And at the right, that's gypsum, calcium sulfate, dihydrate. Calcium was isolated first in 1808 by Sir Humphrey Davy by electrolysis of lime, which is calcium oxide, and mercury oxide. This is how calcium is produced today. One way is the electrolysis of molten calcium chloride. And the second way is a reduction of lime, which is calcium oxide with aluminium metal. Major producers of calcium are China, with 10,000 to 12,000 tons per year. Number 2 is Russia, and number 3 is USA. This is one use of calcium. It's in alloys like calcium silicon, in the steel industry for refining and deoxidation and desulfurization. The calcium alloy reduces the inclusions in steel and gives it better mechanical properties. This is a picture of a limestone quarry in Malta. Limestone is a variant of calcium carbonate. This is another variant, that's chalk of calcium carbonate. This is a white porous calcite variant. It was produced by nature by a compression of plankton deep under the sea. Chalk can be used as a blackboard chalk in agriculture or in toothpaste. It's a mild abrasive. This is a picture of a marble mine near Bursa in Turkey. A marble is recrystallized calcite, calcium carbonate, or dolomite, calcium magnesium carbonate. And Turkey is the biggest marble exporter in the world. This is a famous building, that's the Taj Mahal in Agra, India. It is a marble mausoleum. It was constructed from 1631 to 1653. and is one of the 7 wonders of the world. This is a picture of calcium oxide, CaO. It's also called quicklime. It is part of the lime cycle. That starts with limestone, calcium carbonate. If it's heated to 900 degrees Celsius, it loses carbon dioxide and you get quicklime, calcium oxide. Treatment with water gives you calcium hydroxide, slaked lime, which reacts with the carbon dioxide in the air to back to limestone. That's the calcium lime cycle. This is a picture of calcium hydroxide, it's also called slaked lime, CaOH2. There's a retrograde solubility, which means it is a lower solubility at higher temperatures. It is used for lime mortar and it's a flocculant for sewage treatment. This is a picture of lime mortar. That's the white substance at the left side. It's a mixture of lime, sand and water, and this material was already known in ancient Rome and Greece. Calcium carbide is another interesting compound of calcium, CaC2. Can be made from lime and coke in an electric arc furnace. CaO plus 3C reacts to calcium carbide plus carbon monoxide. It's an endothermic reaction. And this compound can be used as a fertilizer in the steel industry and in carbide lamps. You can produce acetylene and then burn the acetylene. But this is problematic in mines because you have an open flame and that's risky. You have the risk of explosions. This is calcium sulfate dihydrate, it's gypsum, ASO4, H2O. Then comes from Greek gypsos, which means plaster. It's a soft mineral and it's used in the construction industry as fertilizer. Gypsum is also used as plaster for sculptures and as a coagulant for tofu. And another use is in medicine. This is calcium sulfate, also called anhydrite, CaSO4. A natural mineral, it is a bit harder than gypsum. And anhydrite can be used for cement, ceramics, and fertilizer, and for the production of sulfuric acid. This is fluorite. It is calcium fluoride, also called fluorspar. This is the main source for hydrogen fluoride. F2 fluoride plus sulfuric acid produces calcium sulfate plus 2 hydrogen fluoride. And this reaction works because sulfuric acid is a stronger acid than hydrogen fluoride. This is a picture of hydroxyapatite, Ca5PO4 3OH, calcium phosphate hydroxide. It is a main component of bone mineral and teeth. It is used in toothpaste for remineralization to prevent caries. And this is the most stable calcium phosphide compound under physiological conditions. Hydroxyapatite is a main component of bones. Bones are made of a composite material, and the mineral part is 50 to 70%, and most of it is hydroxyapatite with a bit of magnesium ions and a bit of carbonate. Another 30% is flexible matrix made of collagen protein. This gives bones elasticity. And other proteins, lipids, and water in bones. The bone formation is a dynamic process. It is of bone remodeling. Tissue is removed and rebuilt, and that's why it's a problem for astronauts, because in long-term missions they can use a bit of bone material. These are some examples for calcium sources, with cheese, milk, yogurt, sardines, blackberries, and strawberries. Calcium in the human body has a very big importance. There are 1.2 to 1.4 kilograms in the human body. Calcium is important for bones and teeth and blood clotting, transmission of nerve signals, muscle contraction, release of hormones. Hormones are messenger molecules. And the control of the heartbeat. This is the formula of calcium gluconate, C12H22 O14. As E578, it is used as a food additive, for example, for cheese. This compound can also be used for medication in a low calcium concentration in blood by injection. It is listed in the World Health Organization's list of essential medicines. Hence, calcium gluconate can be used for toothpaste, and because it serves as it makes a remineralization. This is a nice picture of today's Pamukkale and former Hierapolis in Turkey, ancient city. It is located in the southwest in the district of in the province of Denizli. This is a picture of the Frontinus Gate at the Frontinus Street. This city is in the UNESCO World Heritage Site since 1988. Pamukkale is one of the most famous places in Turkey. It has 17 hot springs, and it has this barrier structure of travertine material, which is a variant of limestone. And this is Micah. It is a lime plaster statue from Ain Ghazal in Jordan. It is one of 15 statues and 15 busts which were discovered in 1983 and 1985. The statue of Micah is from a time period from 7,200 to 6,250 before Christ. Very impressive and a very beautiful statue. That was today's video about the chemical element calcium. Thank you for watching. Have a nice day. Bye-bye.